welcome to section 2.3, the last part of chapter 2 in our studies of radicals, or those square root functions. Today we're going to show you how to solve radical equations graphically, but I'm also going to review how to solve them algebraically. And you learned how to do them algebraically last year in grade 11 math, so I hope that will not be too much of a big change. But once again, I will show you how to do that. And if you actually have your notes from last year, you can always take a look at chapter 5. I believe that's where you did that. And if you're too lazy to do that, well, guess what? I'll show you again right now. So, let me show you how to do them with graphing technology first. Of course, that's the graphing calculator. If you don't have one, then I'd ask you to find some graphing, program or applet on the web and use that. But on a test, you will need to know how to use the graphing calculator and be able to solve with a graphing calculator. So, here's example number 1. I said solve the equation the square root of x minus 3 equals to 2 using graphing technology. And then I want you to confirm your answer by finding the roots, or that's another way of saying solutions, of the equation algebraically to confirm. So to do the graphing method, there's actually two ways of doing it. If you like just one single function, that's method number 1 on the left. If you like solving a system of two equations or two functions, then that's the one on the right. And I'll show you both. And you decide which one you like from now on. Okay? Method number 1 says use a single function to find the x-intercepts. So the key here is to move all the terms to the left side. So in our equation here, I'm just going to say move all the terms to the left side and set the right side equal to 0. And then what you do is you input the equation on the left side into your y1. So it becomes the square root of x minus 3 and then minus 2. So let me show you that really quickly now with the graphing calculator. Bring it out, go y equals 2, and it's the square root, second function x squared, x minus 3, close the bracket, minus 2, and then let's just do zoom standard, and let's see what you get. You get that lovely graph. Okay, so I'm going to ask you to sketch that out in your notes. So, so I use standard window, so that means that your x min is negative 10, your x max is 10, y min, and by the way, if you don't know where this is, just press window and it'll tell you that. And it looks like the equation looks something like this. So in this case, you want to find the x-intercepts. That's where your answer will be. So right about there. And to find the x-intercept, I'm going to ask you to do second trace, or the calculate feature. Choose 0. Gotta move your cursor to the left of the 0. I don't even see. Oh, there it is. There's my cursor. Press enter. And then move it to the right of the 0. So past the 0. Press enter. Then give it a guess. I'll do that. And lo and behold, oh, it says 7. So this solution here, this coordinate must be 7, 0. So my solution just asks you for the x value. It's 7. Now, if you didn't like that, because you're thinking the roots are really confusing, then let me show you method number 2. Method number 2 says, hey, just separate them as two separate functions. So the left side becomes your root x minus 3, and the right side just becomes 2. And so I'm going to ask you to now put this into your graphing calculator, and you should follow along. And by putting it into your graphing calculator, let's see how the actual graphs change. So let me get rid of this minus 2. Let me go ahead and plug in 2. Let me graph. So now, notice I've got two equations. So I should have actually two lines. I got that graph of the root x minus 3, that's here. And now I've got this interesting line that's at 2. And once again, I'm still looking for the intersection point. So this time I'm wanting you to find the intersection point. So on the calculator, for the intersection point, that second calc, choose number 5. It asks you for the first curve, so move your cursor to be the first curve, at least on your first curve, which is the square root function. So there it is, okay? And then the second curve is my line. There it is. Take a guess. Yeah. And boom, 7, 2. There is your answer. So the intersection point here is 7, 2. And once again, the solution, I'm just looking for the x value, so it's 7. Okay? Same answer. It's up to you which one you like. They are okay with me. Let's just confirm this with the algebraic solution. Don't know if you remember how to do this from last year, but to solve a square root function, we want to get rid of the square root. So we do the inverse operation of a square root, which means we have to, yes, square both sides. And I'll say you do that to eliminate the square root. So if I ask you to square both sides, the square root and square just kind of cancels each other out because they're inverse functions. So you're left with just x minus 3. 2 squared, of course, is 4. So x equals to 7. And you're thinking to yourself, Mr. Lee, why would I even go ahead and use my graphing calculator for this question? You're right. I wouldn't. I do it by algebraic means. But when the questions get more complicated, then you might want to consider using a graphical solution. Little note down here, just want to quickly tell you the zeros of a radical equation. Sometimes they call it the zeros or the solution. Okay, just the answer. Or maybe even the word roots of a radical equation are all equal to, and then if I look at the function, I'm looking at the x-intercepts, okay, of the graph. Of course, that's using method number 1. All right, I think it's your turn now to turn the page. Okay, example number 2. We actually solved this algebraically in Math 11, so I'm going to ask us to do that again here. And then afterwards, I want you to solve it graphically to see if you can confirm your answer. Okay? So, what do we do first if we want to do it algebraically? Everyone says, square both sides. Good. So we'll do that. And be careful when I square the left side. Some people might make that fatal mistake and say this is x squared plus 25, and I will want to strangle you. Oh, don't do that, bad math. Everyone that I know who sees that square just means multiplying by itself and writes it out as two binomials like this never makes that mistake. Because once they write it out like that, they know they need to now expand or FOIL or fireworks, whatever you call it. And that's what you get on the left side. On the right hand side, the square root and the square just cancel out, so we get this. Lots of different terms, so we'll do some algebra now. I'd like you to collect like terms on one side of the equation. X squared minus 11x, I believe, but I'm going to subtract x on both sides. I'll subtract 7 on both sides too, so that's plus 18. This gives you 0. When you see a square term, linear term, constant term, try to factor the trinomial. Remember how to factor? Find two numbers that multiply to the constant 18. Same two terms add to the coefficient of the linear term. That's negative 11. Think of what lovely combinations there are. What times what gives you 18? And then same two things multiply to negative 11. If you said 9 and 2, you're almost right. I want it to be equal to negative 11. So, negatives. So this just becomes x minus 9, x minus 2. Solve, you get x equal to 9 and x equals to 2. Alright, so I'd like you now to go ahead and solve this graphically, same question, and let's see what you get as your answer, okay? Up to you which method you like. I'm just going to use the intersection method just because I've got y1 and y2 here. You don't have to use this method. You can just move everything to one side. It doesn't matter to me, okay? So let me put this in now. Let's see what lovely picture I get. Let me move my graphing calculator over here. We have here clear as x minus 5. Then over here I got the square root of x plus 7. I'm going to graph this out. There's my line x minus 5. Here comes root x minus 7. Okay, this is still the standard window, so that's fine. X minus 5. Whee! X plus 7. What was that? Like this. And I'm looking for the intersection point. So find the intersection point. You do that on your graphing calculator. I'll do that on mine. We'll double check our answers at the end. First curve, second curve, guess. 9, 4. So here we go, 9, 4. So therefore my solution must be, that's an error by the way, x equals to 9. Oh, down here, yeah. X equals to 9. Done. Now, does that confirm my answer from above? I got x equals to 9. Yep. Whoa, what happened to this x equals to 2? I look at my graph and I don't see a solution at x equal to 2. I mean, that would be right about there. And they don't intersect. So what's going on? Well, I hope you remember that if you look at square roots, the largest the actual square root value can be is actually 0. So notice that the right hand side, the minimum here is 0. Well, if the right hand side's minimum is 0, then what about the left hand side? This x. Well, what minus 5 gives you 0? It's 5. So from here, you see that the minimum is actually going to be 5. So the minimum value of x is 5. Or the domain, or the restriction in this case, and we didn't write this down earlier, did we? Our restriction here is that your x value has to be bigger or equal to 5. Because the right-hand side's minimum is 0. So because we didn't put this restriction down, then when we solved our solution over here, we said, oh yeah, x equals to 9 and x equals to 2. But it doesn't, because x equals to 2 is what we call an extraneous root. The algebra makes sense, but when we actually double check and plug it back in, it doesn't. Okay? If you were to plug in 2, right, to the equation, you get 2 minus 5. That equals to square root of 2 plus 7. Well, 2 minus 5 is negative 3. 2 plus 7 is 9. Square root of 9 is 3. So, don't make sense. And that's why the graphical approach is really nice, because you won't get these extraneous roots. You only get the solutions that make sense. Okay. Next page, example number 3. Okay. See if you can do this one on your own. Okay. At least graphic, I hope you do your own. Maybe the algebra part you forgot how to do, but nonetheless we use the same idea, the same concepts. To get rid of the square roots, we have to square both sides. So once again, I'm going to ask you to square both sides, but please be aware you're squaring the entire left side and the entire right side. So squaring this, you get 2x minus 5. Squaring this, once again, please make a note. Okay, write them out as 2 brackets, and you won't make that fatal mistake. 1. The root x minus 3. And then another one. And then now root x minus 3 times root x minus 3 would just be an x minus 3. Okay, I still ask you to collect like terms and collect the square roots together. So 2x minus 5. 1 minus 3 is negative 2. You got 2 of these root x minus 3s. And you also have an x. Okay. Let's subtract x on both sides. Let's add 2 to both sides. So that'll be x minus 3 equals to 2 root x minus 3. Now we still have a root here, right? So we're going to have to actually now square both sides again. Okay, so not just once, but twice, since you have 2 square roots. Square both sides again. X minus 3. Now once again, I'm going to ask you to multiply or write this out as 2 separate things. When you do that, you won't make mistakes. 2 times 2 is just equal to 4. And then the root x minus 3 times root x minus 3 is just a factor of x minus 3. Go ahead now and expand and simplify. That'll be 4x minus 12 equals x minus 3. We'll simplify by, I guess this time, I'll subtract x and add 3. Subtract x, add 3. Oh, wait a minute. No, I want to isolate the variable. Forget that plus 3 thing. Why don't I add 12 to both sides instead? Yeah, that would make more sense. So 3x on the right-hand side. How about, do you know what I did wrong, everybody? Yep. Oopsie daisies. What did I do wrong? I got too excited, didn't I, in that line in black? What did I forget to do? That's right. I forgot to square the x minus 3. Ay, 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 ay. So, sorry about that. We will go and distribute this as well. X squared minus, I think, 6x plus 9. Sorry. Should have spoke up earlier. Oh, wait a minute. You're watching a video. You can't speak up. Oh, well. Subtract now 4x and add 12 to both sides to move everything to one side. So minus 4x and then add 12. Looks like I got to factor again. Find two numbers that multiply to 21 and add to negative 10. How about negative 3 and negative 7? Which leads me to my answers of x equals to 3 and x equals to 7. Now, when you're doing algebra in grade 11, I always told my students, go back and check your answers. So you can go back and check your answers, but because I'm going to solve this graphically anyways, I'm going to be a little bit lazy here and just solve it graphically, and let's hope that they're the same. Okay, and if they're not, then I'm going to have to get rid of one of these answers, because just like example number 2, it's probably extraneous. So I'm going to ask you to graph this one out. Let's see what you get. Okay. I like having 2. Okay, clear. 2x minus 5. 1 plus root x minus 3. Go ahead and graph and let's see what you get. There's my square root graph, the first one. Oh, there's my next one. Kind of hard to see here, isn't it? Let me try to zoom in. Let's zoom box this time. I like zoom box. Okay, because I'm thinking the interesting stuff seems to be happening right about here. So let's go ahead. Enter. First function, second function. Ooh. Okay, let's find some intersection points. Boom, boom, boom. Is one of them 7? Yes, it is. Cool. Why did I know it's 7? Because I saw from above x equals 7. So yeah, x equals 7. Now you should draw the picture too. I'm just too lazy. Draw picture. And let's find the other one. Let's go intersect again, but this time I'm going to move closer. Now, you see how the graphing calculator doesn't really look like it intersects down there, just around here, but I think it actually does. So let me move closer over here, press enter. Let me once again move closer to the actual 0. Press enter. Interesting. It only gives me the other one. So, does 3 not work? Let's take a look. I'm going to go to second table in this case. So, here's the x values, and look at my y values. There's the error there because you're taking the square root of a negative number. But notice at 3, it seems like both y values are the same. They're 1. And same thing at 7. They are. Same. So in this case, actually 3 and 7 both work. But unfortunately, your graphing calculator kind of fools you and says it doesn't match. So perhaps this intersection method doesn't work as well. Maybe what I should do is try to use the zero method. And let's see what happens when I do the zero method, where I now move every single term to the left side. Okay, so let's try that. And let's see what you get. We've got the square root of 2x minus 5 minus 1 minus now the square root of x minus 3. Let's just take a look at what happens here. Okay, let me delete y2. And then let's go zoom standard. Number 6. Let's see what you get. Whoa. Interesting. So once again, it looks like our graph should focus in on this little area. I will go zoom box once again. Oops. And you know what? This one, not too sure if it'll be better or not, but we'll find out. Press enter here. Let's make my box. Scroll down to the left. Press enter. Dun, 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 dun. So it only shows you the 0 here at 7. It doesn't show you the 1 over here because I think it's too close to the actual starting value. Well, I guess in this case here, this one just kind of illustrates to you that, hey, solving the equation is a much better way of doing it. I think if I use the table, yeah, then it'll show you 0. See? 3, 0, 7, 0. Okay, well, either or. I think both these equations are fine, but in this case, be warned. You may want to use the table function. May want to use the table function to help find answers. Okay, and this is true especially if a solution is one of those like starting values, or I'll say left endpoint values. Remember how we did left endpoint in section 2.1? Yeah. Okay. So once again, graphing has its advantages because in the previous question we need to get rid of those extraneous roots, but in this one, maybe some disadvantages because we couldn't find the solution when it was one of those starting values. All right, one more on the back page. I'm going to ask you to try that graphically, and then we will also show it to you algebraically. Okay, it's up to you which method you like. Once again, I'm going to be quiet now, and I'll just do my method. You do yours. We'll come back and double check. And then afterwards, we'll do the algebraic one as well. And maybe I don't even need to say that to you. You can just do it on your own. And let's see if you can double check your answers. Okay? So why don't you stop the video, see if you can do this on your own, then come back and double check my answer. I'll do my answer really quick. Okay? Go. Oops, mistake. I should change my window coordinates to zoom standard. There we go. Oh, why did it pause? Interesting graph. Probably want to change this, make it a little bit higher perhaps. I'll change my window. Maybe X max to like 15. Seems like there are two intersection points, so we'll do that. Calculate intersect. First curve, sure. Let's do the one on the left first. Second curve. So one of my solutions is negative 2.09902. So how about negative 2.1? So x equals to negative 2.1. By the way, you draw your own picture. You will need to draw a picture on the test. It's like showing your work. 8.09, 8.1. Okay. Alright, those are the solutions graphically. Now go ahead and try to do them algebraically. Algebraically, alright. Square both sides, shall we? X plus 3 times x plus 3. Square root of that, all squared. Move everything to one side. I'm going to move everything to the right side this time because I see the right side having 2x squared. Minus x squared. Minus x squared. There's x squared. Minus 6x. Minus 6x. Minus 6x. Negative 9. Minus 9. Alright, I usually factor. This time I'm thinking to myself, two numbers multiply to negative 17. Same two numbers add to negative 6. 17 is prime, so it's only 1 and 17 that multiply together to give that. Not a chance to get negative 6, so I guess there's no solution, right? Think again. If you can't solve it by factoring, you can always use the quadratic formula. Those of you who had me before, remember the song? Yeah, sing the song. Good stuff. Alright, so just plug it in. There's your quadratic formula. X equals to negative b. So negative of negative 6 is 6. Plus or minus the square root of 6 squared. Or sorry, negative 6 all squared, which is just 36. Minus 4 times 1 times negative 17. All over 2 times a, which is 1. What's that? 36, 68, 104, I believe. Yep, all over 2. Since it's a decimal answer, I'm not even going to simplify that radical. You could if you wanted to. I'm just going to go straight to the calculator to find what that is. How about 6 plus the square root of 104? Then divide that by 2. So our positive answer is 8.099. Well, that's what I had before, right? That's like 8.1. And if I were to take the negative square root, let's see what I get. Let's take the negative. So minus, 6 minus the square root of 104. Divide that by 2. Oh yeah, negative 2.1. Life is good because the answers make sense. Just want to end off this section by asking you to think about this. What are some advantages and disadvantages of solving radical equations either using graphical approach or an algebraic approach? I'm not going to give you the answers here, but I will ask you to discuss that when we come back to class. So, there you go. 2.3 is now finito. That means finished.